Hi dear students, welcome to lecture 7 of motion in a straight line. So in this lecture, we will be discussing some of the important graphs. Okay, that is the graphs of body at rest, body having uniform motion, body having uniform acceleration, and also some of the graphs that cannot exist. Okay, so before discussing different graph, let me tell you some of the basic things that you want to know. Okay, first of all, if you have y is equal to c, okay, where c is a constant means it can be a number like 5 0 1 2 3 minus 1 minus 2 minus 3. Okay, these numbers are called as constant. So you have y is equal to c, where c is a constant. That means the graph will be parallel to x-axis. Okay, that graph will be parallel to x-axis. Now, you will have a polynomial, right? A graph means a graph will have an equation. You all are familiar. You have learned linear equations in one variable in 9th standard, linear equation in two variable in 10th standard. Okay, and also you have learned about circle, etc. So every graph or curve will have an equation. And if the degree, or we can call it as a polynomial, right? That equations can be a polynomial. And if the degree of that polynomial, okay, if degree of polynomial equal to 1, then graph is straight line. Graph is straight line having a non-zero slope. Non-zero slope. Okay. Here, in the first case, when y is equal to c, where c is a constant, graph will be parallel to x-axis, right? Or you can say slope is equal to 0. Why? Why? We know that m is equal to tan theta, right? M is equal to tan theta is the equation to find the slope. Okay. If something is, this is x-axis and this is our y-axis. So if a line is parallel to x-axis means the angle made by this line with x-axis, okay, this angle made by this line with x-axis will be 0 degree. And we know that tan 0 is nothing but 0. Okay. So if a graph is parallel to x-axis, the slope will become 0. Okay, because angle is 0. So tan theta will become 0. Okay, clear. Now in this second case, the equation of that graph have a degree 1. We know what is degree. It is the highest power of the variables in that equation. Okay, if the degree is 1, then the graph is again a straight line. Okay, but that line will have a non-zero slope. Means it may be something like this or like this anyway, whatever it is. It should have a slope. That is, it is not parallel to x-axis. It should make an angle with the x-axis. Clear? Okay. Have I explained these 2 points in detail? Okay. And this may be a concept you already know from 10th standard itself. You have learned in mathematics. Okay. Now the third point is if degree of polynomial is equal to 2, then the graph is a parabola. Okay, then the graph is a parabola. If the degree of polynomial is 2, then the graph is parabola. Okay, you already know what is a shape called parabola and all, right? So now we will come to the first one, that is a body at rest. Okay, suppose a body is at rest, then we know that the velocity of the body is 0 because the body is at rest. Okay, then the velocity is 0. We know the equation. Velocity is nothing but it is the first derivative of displacement. You have came across this equation in the previous lecture, right? How it becomes dx by dt. So which means that dx by dt is equal to 0. Dx by dt is equal to 0. Okay. When will the derivative become 0? Dx by dt means it is the derivative. Okay. When will the derivative become 0? Only when this quantity is a constant. That means x is a constant. X is a constant. Clear? X is a constant, which means displacement is a constant. Okay, displacement is a constant. Clear? So how will the graph look? The graph will be something like this. This will be the displacement time graph for a body at rest. Okay, this is the displacement time graph for a body at rest. Okay, so displacement is a constant means the position of the body is not changing. We will have a velocity when the position change. We know that only when position change with respect to time, we will have velocity. The velocity 0 means there is no change in position by the passage of time. So you observe this graph. Okay, you observe this graph. The time is changing. Okay, the time is changing. Okay, but the displacement value, here you will have a value. Suppose it is 1 meter. That displacement value does not change. That displacement becomes a constant. The time is increasing. Okay, the time is increasing, but the displacement is always 1 meter. Clear? Yes. So this is the graph for a body at rest. I hope you clearly understand this, okay? Now, we will discuss for a body having uniform motion. Okay, we already know what is a uniform motion, right? Uniform motion means uniform. The word uniform means constant. Okay, and uniform motion refers to constant velocity. Constant velocity. So here you can say the velocity is c. C means a constant. Okay, velocity is a constant. Velocity is a constant. If something is a constant, then how will the graph look like? The velocity time graph, will be parallel to x-axis. The velocity time graph will be parallel to x-axis. This is the VT graph. VT graph. Okay, this is the VT graph for a body having uniform motion. Okay. Now let us see what will be the displacement time graph for a body having uniform motion. Okay. Let us see how to draw the displacement time graph. ST graph. Okay, the ST graph for body having uniform motion. We know the equation to find displacement is integral V dot T. So velocity is a constant, right? So you can put it C dt. Clear? Velocity is a constant. We have already told. Uniform motion means the velocity should not change. So V is equal to C. So here instead of V, okay, instead of V, we will put C. So integral C dt. That C is a constant, so it will be taken outside the integral symbol. So integral dt. Integral dt you already know. If integral of something will change, it will be t, right? You already know that. So it is Cs. Sorry, CT, right? It is CT. Okay. Now this is the equation for displacement. This is the equation for displacement. Who is the variable? C is a constant. T is the variable, right? What is the power of T? What is the power of T? You can see that. You can see that the power of T is 1. Right? So the degree is 1. Degree is 1. If the degree is 1, how will the graph will be? If degree is 1, the graph will be a straight line having a slope. So this is the displacement time graph. This is the displacement time graph for a body having uniform motion. Clear how this graph became like this? Okay. Now, what will be the acceleration time graph for a body having uniform motion? What will be the acceleration time graph for a body having uniform motion? Let's try to draw the acceleration time graph. Let's try to draw the acceleration time graph. Okay. We know acceleration is dv by dt. And here v is c, right? So dc by dt. What is derivative of a constant? What is derivative of a constant? 0. Right? Derivative of a constant is 0. So here acceleration is 0. Acceleration is 0. We already know that when the motion is uniform motion, the acceleration will be 0. Right? So no graph. No graph. Okay, acceleration time graph. For acceleration time graph, you cannot draw a graph. Clear? Because the acceleration is 0. Now let us say about body having uniform acceleration. Okay. For a body having uniform acceleration, we want to draw the acceleration time graph, velocity time graph, displacement time graph. Okay, we want to draw 3 graphs for representing uniform acceleration. So case 1, let's start with acceleration time graph. Okay, acceleration time graph. See here also uniform acceleration. The word uniform means constant. Clear? Constant. So it is constant acceleration. Constant acceleration. So you can say that acceleration is constant, right? So acceleration is equal to c. C is a constant. So how will the graph look like? Parallel to x-axis. Clear? The graph will look parallel to x-axis. Okay. Now we will go to the second case. Case 2. Let us try to draw the VT graph. Let us try to draw the VT graph. In order to find the velocity, we have the equation velocity is equal to integral of a dt, and we will substitute for a. A is nothing but c. So c dt. C will be taken outside. It is integral of dt. Integral dt means it is t, right? So v is equal to ct. So you can observe the degree is nothing but degree of this polynomial is 1. Okay. So how will the velocity time graph look? It will be like this because degree is 1. So it will be a straight line with a non-zero slope. Clear? Now let us see case 3. There is acceleration time graph. Acceleration time graph. Sorry, we have already done, right? Yeah, we have already told about acceleration time graph. Case 3 will discuss displacement time graph. Okay. We'll discuss displacement time graph. Okay. So we know the equation for finding the displacement is integral of v dt. Integral of v dt. And what is the equation for velocity? The velocity equation we have already found here. It is velocity is ct. So let's put here ct dot dt. C will be taken outside. It is integral t dt. Integral t dt. Okay. In the next lecture, I will be discussing about how to do the integration. Okay. So now you just understand integral of t means it is t square by 2. That's the answer. Integral of t dt means it is t square by 2. I'll tell you how it became t square by 2 in the next lecture. Okay. So you get the equation for displacement. And what is the degree? What is the degree? The degree is 2. The degree is 2. Then the graph will be a parabola. We have already discussed that concept. If the degree is 2, then the graph will be a parabola. So when you draw the displacement time graph for uniform acceleration, you are drawing displacement time graph for uniform acceleration. The graph will be a parabola. Okay. Actually, you know, this is the shape for parabola. But here we are considering, we are starting from time 0. Okay, the displacement is positive. So you just need the half of this parabola. Clear? When time is 0, the displacement is 0. Okay. So these are the things we have discussed. We have discussed some basic concepts that you must be knowing. That is, when you have something as constant, graph will be parallel to x-axis with slope 0. If degree of the polynomial is 1, then graph is a straight line having a non-zero slope. If degree of polynomial is 2, the graph is parabola. And we have discussed the displacement time graph for body at rest. Velocity is 0, so there cannot be a velocity time graph. Okay, velocity is 0. So this will be the displacement time graph. Then we have discussed velocity time graph for body having uniform motion. We cannot have an acceleration time graph because acceleration is 0. Then ST graph, right? That is displacement time graph for uniform motion. Okay. And why the shape of this graph is like this. This all are discussed in detail. Okay. Then we have discussed the graph for uniform acceleration. Okay. For that, we have drawn the acceleration time graph. We have drawn the velocity time graph. And we have also drawn the displacement time graph. Okay. You just want to remember the shape of these graphs. Okay. And the reason behind such shape have been discussed mathematically. Okay. Now let us see some graph that do not exist. Okay, some of the graph that cannot exist. So this is the first among that. It's a velocity time graph. Okay. This is the graph. This graph is not possible. Do you know why? I'll tell you. Okay, I'll tell you that. See, here, if there is a time here like 6 seconds. Okay, you assume that here is a time 6 seconds. At this 6 seconds, there is a velocity value like 5 meter per second. Okay. And also you can observe if you extend this line will touch at this point. There can be a velocity like 10 meter per second thing. So for a single time, 6 seconds, you are getting two values for velocity. Is that possible? A body have two velocities at a single moment. That is not a possible case, right? So this graph cannot exist. Clear? This graph cannot exist. So you can write the reason. to value of velocity, displacement or acceleration at particular time is not possible. Clear? So what I have drawn is a velocity time graph. If they give you such an acceleration time graph, then this is not possible. If they give you a displacement time graph of this model, it is not possible, because at a single time or at a particular time, there can be only one value for acceleration, displacement or velocity. Okay, there cannot be more than one value. So any graph that is giving you more than one value is a wrong graph. Now let us draw another graph. This is time, here is speed, and I'll draw the graph. This is the graph. Okay. So my question is whether this graph is possible. This graph is not possible. Why? Speed is a scalar quantity. Okay, speed is a scalar quantity. And the graph shown here, this is a graph, right? This one is the graph. This graph is negative. Can a scalar quantity be negative? Can speed be negative? No. Can distance be negative? No. We have discussed that points, right? When we was discussing about distance, displacement, speed, velocity, etc. So I could say it is not possible. Okay. So you can say that speed or distance, okay, in general, speed or distance can never be negative. Speed or distance can never be negative. Okay. Now let us draw another graph which is not possible. Okay. So here is a xt graph or st graph, whatever it is, displacement time graph basically. And this is our graph. Okay. So is this possible? No, because here the values of displacement is increasing without change in time, right? Here you will have a value like say 5 seconds. Okay. So there is change in position. There is change in displacement. You can observe here the displacement is increasing, right? The graph is going up. That is displacement is increasing. But the time is a constant. Is that possible? Never. Because we have discussed the definition of motion. The definition of motion was the change in the position with respect to an origin or a reference frame with the passage of time, right? The time should pass, the time should increase. Clear? But here time does not change. So we can say the reason for that. Okay. You write the reason. It is not possible. It is not possible to change any quantity without consuming or changing time. Okay. Without consuming or changing time. So the time must change. Okay. Clear? So in the next lecture, we will be discussing about area under the graph of a vector quantity and also we will discuss the mathematical operation, that is some basic formulas only. Okay. In detail, you will learn in your mathematics in +1 and +2. So we will discuss the basic differentiation and integration required to learn physics concepts. Okay. So see you in the next lecture.